Hi, my topic is K-means and expectation maximization. So, before going into this K-means and expectation maximization, let's first see what is clustering. Clustering is the process of dividing the datasets into groups consisting of similar data points such that points in the same group are as similar as possible and points in different groups are as dissimilar as possible. And clustering is basically an unsupervised machine learning technique. Now, there are many clustering algorithms, of which the simplest one is K means. The main goal of K means clustering is to group similar elements into a cluster, and it is an exclusive clustering technique. That means the clusters does not overlap, or each point will exclusively belong to just one cluster. Now, it is to be noted that this k in k-means indicate the number of clusters. Now, coming to k-means algorithm, the first step is to identify the number of clusters we want. Now, by barely looking into this figure, our eyes automatically does a clustering that divides that groups these points into three clusters, right? So here we take k as 3. But how can we choose this value of k in a systematic way? So there are some methods for that. We will come to it later. Now, uh, for instance, we take k as 3 and let's proceed to the next step. In the second step, we have to select k number of distinct data points. We have to randomly select k number of distinct data points. Here we have taken k as 3. So I have chosen three distinct data points, this blue one, this red one, and this yellow one. Now these selected points can be called initial points or centroids. Now the third step is to find the distance between this first point and these initial points. That means we have to find the distance between this point and blue one, and the first point and red one, and also distance between the first point and yellow one. Okay, now here we can see that this first point is more closer. That means the first point is closest to this blue one than this red one or yellow one. So in the next step, we will assign that first step to this blue cluster, since that is the more closer one to the first point. So we will assign that first point to the blue cluster. Now similarly, we will repeat all these steps for all the other subsequent points, and finally after assigning each point to each cluster, finally we will get something like this. Now what we have to do is to calculate the mean of each cluster. Here these vertical lines represent the mean of mean position of each cluster. This blue line represents the mean position of this blue cluster, this red line represents the mean position of red cluster, and this yellow line represents the mean position of yellow cluster. Now we have to repeat all these measuring and clustering steps, but with the difference that the distance will be taken between each point and these mean positions. Earlier, we had taken the distance between all the points and centroids or initial points. But here, we had to take the distance between all the points and these mean positions. And then we will assign each point to that cluster whose mean position is more closer to that point. Okay, so that's how it is to be done. And finally, we will get such a cluster. Okay, but this looks very different from what we had expected in the beginning, right? We had expected such a clustering, but what we have got now is this one. So that means we have to improve upon our clustering. So for that, we will start right from the beginning again. But here, we will take some other points as initial points. So I have chosen these 3 points as initial points this time. Now we will repeat all the previously mentioned steps. And finally, we will get this cluster. Now this is same as what we had expected in the beginning, right? So this is the process of k-means. Now let's look into the flowchart of K-means algorithm. Uh, as I have said earlier, we will choose a value for K, that means the number of clusters. Then we will select K number of centroids or initial points from the totally given data points. Then we will find the distance between each point and centroids, and then further we will find the distance between each point and mean positions, and we will do clustering by assigning each point to a cluster, and we will repeat all these steps till the clustering does not converge till the clustering does not change any further. That means so we have to repeat these steps until there occurs no change any further in the clustering. So that will be the end of the flowchart of K-means algorithm. Now, okay, now coming to the point I had said earlier, that means how to find the value of K in a systematic way. So there are two methods for that. The first one and the most popular one is this elbow method. In this method, we will try different values of K, and for each of this value of K, we will find the average distance from the centroid to each of the other points, and then we will plot these values in this form. That means in x-axis we will take the value of K, and in y-axis we will take the average distance. And now in this figure we can see that this graph looks like an elbow, right? So in this we have to find that point where this folding occurs, or it is that point where occurs a huge reduction in this average distance, and also after that point that reduction in average distance will not be that significant. Here we can see that when k equal to 3, there occurs a huge reduction in average distance, and after that the graph is not that steep. Till then the graph was a little bit steep, but after that it's not that steep. So that's how to find the value of k. So in this case the value of k will be 3. So this is one method. Now the next method is called Silhouette method. This is the formula, Silhouette formula, that is S of I equal to B of I minus A of I by the larger of B of I and A of I, where I is any data point. Now what are this A of I and B of I? We'll come to it. Okay. So we have k number of clusters, right? So in that we will consider one cluster, any one cluster, and in that we will choose one point I, one data point I. Now A of I indicates the average distance of this point I to all the other points in the same cluster. That means we have to find the distance between I and all the other points in the same cluster, and then we will take the average. So that's given by this A of I. Now coming to B of I, it will be the average distance of the same point I to all the other points in the nearest cluster. So that's the difference. In first case, in the case of A of I, it was the average distance of all the points in the same cluster, whereas in B of I, it's the average distance with all the points in the nearest cluster. So we will, in case of B of I, we will take all the distances uh, between all the other points and this I, and then we will take the average. And the larger among the A of I and B of I will be the denominator. And by this formula, we will find the silhouette value in case of all the values of k. That means as we had done in elbow method, we will try for different values of k, and in each each case of each and in each case we will find the value of S of I. Okay, so for different values of k, we will find this value of silhouette. We will find the silhouette value and we will plot it like this. Here only the plots for k equal to 3 and k equal to 4 are shown. That means the values for values when, sorry, values when number of clusters is 3, and values when number of clusters is 4. And it is to be kept in mind that the ideal value of select is 1 and the worst possible value of select is -1. Now by looking into this graph, we can see that when k equal to 3, there are many values that tend towards 1. So that's a good symbol, good sign. But when k equal to 4, there are not much value that tend towards 1 as when k equal to 3 as compared to k equal to 3. And also there are many values, even there are many values that tend towards the negative side, that means towards -1. So that's not a good sign. So k equal to 3 will be a better option among these two. So this is how to find the value of k in select method. That means we have to select that value of k whose values tends largely towards 1. So that these two are the common methods used for finding the value of k in a systematic way. Now, till now, I had been explaining about k-means process in 1D data. That means the data points plotted in a single line. But that will not be the usual case. Usually, the data will be the data points will be plotted in a graph or in a 2D manner, or sometimes ND manner. Okay, ND data also will be. We will have to use ND data also for doing k-means process. But what will we do in that case? I had been explaining about the processing 1D data, okay, but we will have to use the same process in ND data also. So in that case, what will we do? So in that case, everything will be same. Every step will be same, except that instead of considering this normal distance between data points, we will have to use Euclidean distance. Now, what is Euclidean distance? The same as this Pythagoras theorem. The formula is given here. This is the formula in case of 2D data, but we can extend this formula to ND data also. That means this is same as Pythagoras theorem. That means if we had to find the distance between these 2 points, this point A and point B, that means we had to find this distance. This is the Euclidean distance between these points. For that, we will take the square of these two distances, and then we will sum up those distances, and then we will take the square root of that sum. So that's how we will find this distance. That means to find this distance will be equal to the square root of sum of squares of these two distances. So that's the Euclidean distance. Now we can extend this to ND data also. This is the only difference between 1D k-means in one dimensional data and n-dimensional data. Now coming to the advantages and disadvantages of k-means. First, let's look into the advantages. K-means is very easy and simple to understand as well as to implement. So that's an advantage, and it will scale up to large data sets also. And a convergence is always guaranteed in the k-means process. Now it's also easy to adapt new examples in case of k-means. Now let's look into the disadvantages. We have to choose the value of k manually. That's a disadvantage. We will have to either use this elbow method or select method or some other methods to find the value of k, to choose the value of k. So we had to do it manually, so that's a disadvantage. Now our data may sometimes consist of some outliers. So while doing this k-means, it may sometimes cluster these outlier values also. Sometimes all the outlier values may cluster up to form, may group up to form a cluster. So that's a disadvantage. Now if the data is of varying sizes and density, k-means will be little bit troublesome to perform. So these are the advantages and disadvantages of k-means. Now coming to the application of k-means, the main application of k-means is document clustering. Now it's also used in market segmentation, image segmentation, image compression, and there are a lot more applications of k-means. So that's all about k-means. Now coming to the next topic. Now you all may be familiar with the maximum likelihood estimation. Well, it has some limitations. That is, it assumes that all the data and variables that are relevant to the model are already present in the given data. But sometimes that may not be the case. That means sometimes some relevant variables may be missing. But these missing variables will not be seemingly visible. So these seemingly missing variables are called these latent variables. Now, if such latent variables are present in the data, then MLE will not be very effective. So, in this case, one approach that can be used in this case is called expectation maximization. Now, clustering usually deals with grouping similar objects together and separating dissimilar objects to different clusters. Now, EM gives an extension to this. In addition to identifying the clusters, EM also determines how the clusters are different. Now let's see what's the difference between k-means and expectation maximization. While k-means assign each observation to different clusters, what EM or expectation maximization does is that it actually calculates the probabilities for one observation to belong to a cluster. It actually calculate the probability. So that's the difference. Now let's look into the EM algorithm. In step 1, we will be given an incomplete data. That means in that data some latent variables may be present. That means some variable may be some relevant variables may be missing. So that's why it's called incomplete data. Uh, so uh, that's the first step. We will be given a data, and in the second step is called expectation step. It's also called E step. Now in that step, we use the observed data. That means the incomplete data we use that incomplete data, and with that data we will estimate or guess the values of the missing data. Now the next step is called the maximization step, or it is also called M step. Now in this step we use the complete data now generated. That means now we have it was an incomplete data that we had, and we have estimated or we have guessed the missing values based on the data that is available. Now it has become somewhat complete data. Now using this complete data now generated in the second step, we will try to update the values of parameters. So that's what is done in the third step. We will update the values of parameters. Now in the fourth step, it is checked whether the values are converging or not. Now if yes, then we will stop, or uh, if it does not converge, then we will repeat the steps 2 and 3 again and again until it converges. Now this is the procedure of expectation maximization. Now coming to the advantages and disadvantages of EM. Firstly, advantages. It's always guaranteed that likelihood will increase with each iteration. That means there is always an improvement that is guaranteed after each iteration. Uh, with each iteration, some improvement will be always there. So that's guaranteed. And also, the E step and M step are always very uh, easy to implement. So these are the two advantages of EM. Now coming to the disadvantages. Even though the convergence is guaranteed, the process will be little bit slow. So that's a disadvantage. Now the convergence will be always towards this local optima or local minima or maxima. There will not be any details regarding global optima. That means global maxima or minima. It will be towards this local optima only. So that's a disadvantage. Now in this process, we will be having to find the probabilities, both the probabilities, that means forward as well as backward. So that makes this process a little bit difficult. So these are the disadvantages. Now coming to the applications of EM, expectation maximization is used for data clustering in machine learning, computer vision, etc. EM is also used in natural language processing, and it is also used for parameter estimation in mixed models, in quantitative genetics, in psychometrics, etc. So these are the applications of expectation maximization. So that's the end of the topic. Thank you.